Hello friends, today we'll derive the magnetic force on a current carrying conductor placed in a uniform magnetic field. So nothing none other than the magnetic force. Okay, we will derive the magnetic force. Okay, it's simply. So go, here we go. So we know from the general formula of magnetic force is dq. Okay, it's if it's df, then it will be dq v cross b. Okay, but we are deriving it for a uniform magnetic field. Okay, so let's go. We know that the v is equal to dl by dt. Okay, velocity is equal to dl by dt, differentiation of distance with respect to time. Okay, this is the v. So we know, now put this value here. Here is b cross, okay, df. Now what we'll do, we'll take dt out. If we're taking dt out, it will become this dl cross bl. So this will be in the vector form and this will become I. Okay, dq by dt will become I and it will dl cross bl and it is df. Now what we'll do, we'll integrate both sides. If we'll integrate both sides, it will become fm, and we know if we integrate the dl, it will become the l. Okay, so I equal to l cross b, I into l cross b. Okay, so this is our magnetic force on a current carrying conductor placed in a uniform magnetic field. Thank you. Let's look at the derivation once. Hello friends, today we'll know the concept of how charged particle moving in a uniform electric field. Okay, so that is the concept we're gonna do, and so let's go. So we should know the acceleration. Okay, the acceleration is a f by m, and we know the electrostatic force is equal to qe by m. Now apply the formula of S equal to ut plus half at. It is one of the formula of the motion of motion. Okay, it is one of the formula of motion of equation. So we know, okay, so it will be the concept of the projectile. Okay, so if we considering x is equal to distance will be x, okay, in the horizontal. Okay, so ax, its acceleration will be 0. Okay, ax also will be the 0. With this concept will applying, or u equal to v. Okay, so here s equal to x, u equal to v, t plus here acceleration is equal to 0. Okay, so x equal to vt. This will be the equation 1. Now what we'll do for y. Okay, now we are finding for the y. So y equal to ut plus half at, it is ay t square. Okay, so in general you can write a. Okay, don't need to write, but here here you see this this initial velocity will be 0. Okay, so y equal to half a t square. Okay, this is gonna be this, because u is going to be 0. Now from equation 1 we can say t is equal to x by v. Okay, take this as equation 1, not this. Okay, take this as equation 1, and now put this equation 1 in here. If you put, you will get, and put a, okay, let it equation 2, not 1, and equation 1 will be your this. Let it equation 1, let it equation 2. Okay, this will be 2 and this will be the 1. So put 1 and 2 in this equation. So half will be the half, a will be this, and in the instead of t square we'll write x by v. So if we putting t here value, so x is square, it will become x square and v square. So go ahead, it will be x v square. Okay, now here y equal to half q e m x square by v square, and this will be the constant. So we can take this as k. So y equal to k x square. Also the v also be involved in this k square. K is here constant, half q e by m by v square. Okay, this will become y equal to k square. That means y is proportional to x square. Okay, y is proportional to x square. If y is proportional to x square, the given equation, the equation is parabola. Okay, so the equation is parabola. So this is it. For revision, first we'll find a, the acceleration. Then here acceleration is 0, so in u will become v. So x is equal to vt, and here t is x by v. So first equation, second equation, and this will be the third equation. Put 1 2 in this equation, you will get this, and finally you will get this. And take k equal to, that is a constant. Okay, constant, and put there, you will get y proportional to x square. This shows the equation is parabola. Okay, that's it. Hello friends, here we'll find what happens when the charged particle moves at an angle to a magnetic field other than 0 degree, 90 degree and 180 degree. Okay, so let's go. So if you look, we know the pitch of helix. Okay, pitch of helix is the linear distance. Okay, so first of all we move to the basic thing, which is the magnetic force. Magnetic force is q u b, but here it will take in the sign direction. Okay, because if we also separating eliminating the cross product, we have to write v sine theta. Okay, so if we're taking the velocity would be the vertical, v sine theta. So what is the circular centripetal force? mv square. So we'll write mv square by r. So r, now v square will be v sine theta square. Okay, qv sine theta square. Here 1v will be cancelled. Also the 1 sine theta and 1 sine theta will be cancelled. So it will left 1v sine theta by r is equal to qv. Now r is here is equal to qv sine theta by qv. r is equal to this. So we got our radius, and here is nothing change. Okay, here if you asking the time period will be same as usual. Okay, okay, same as we proved in the same we proved in the previous video. Okay, time period will be the same. Okay, now what we'll do, we will find the pitch of helix. Pitch of helix is the linear horizontal distance. Okay, so here is a v cos theta will be involved. So now we'll finding the pitch of helix. Pitch of helix is p equal to v cos theta t. It is a distance. Okay, velocity into time is what? It's the distance. So but we'll taking velocity in the cos in the x direction. So that's why it is a v cos theta. Okay, so let's go. T, for t we put this value here. Okay, so it will become 2 pi m v cos theta by qb. It is a pitch of helix. So done. Look at all the questions, all the equations and results. Thank you. Hello friends, today we'll know the magnetic field due to a current in a circular arc of wire. Okay, so today we'll find the magnetic field due to a current in a circular arc of wire. So this is a wire of circular wire. This is a theta and this is the elementary theta d. So if we cut the part of circular arc, so it will be the dl. It is a displaced elementary displacement or elementary distance, whatever you can say, and I is the current flowing. Okay, let's go. So from Biot-Savart law we know, dB is equal to mu naught by 4 pi I dl by r square. So from here, if we integrating dB, so this is the exact equation. So u naught by 4 pi I by r square will be the common one. Here we left with dl, but here dl will integrate 0 to theta. But here is the question around. Okay, what is dl? So we know theta is equal to L by r if you considering it as an arc. So if we'll taking L as a elementary, then this will become the elementary, d theta will become the elementary. So here dl is equal to r d theta. Okay, now we'll put the value I by r square. So instead of dl we'll write r d theta from 0 to theta, and here r will be the common. Here r will be the common. So 1r will be cancelled and 0 to theta. Now it's u naught by 4 pi IR by theta. So this is a magnetic field. So this is our final result and this is our final answer. So look at the whole equation at once. Thank you. Hello friends, today we'll know the concept of charged particle moving in a uniform magnetic field. Okay, so previous video we'll deal with the charged particle moving in a uniform electric field. Now it's uniform magnetic field. Okay, it's visible to all. Now it's visible. So here is a magnetic field. Okay, so let's go. So take a circle. So if here is a F force, then here is a V. Take the F forces. the F V, here is the F V. Okay, so let's go. We know the magnetic force from the general definition of magnetic force is like magnetic force is equal to QUB sine theta. Okay, so if you take theta as like take theta is equal to 180 degree. If you are taking 180 degree, it will become 0. So Fm will become 0. So it's not gonna be work. Okay, so now we'll take theta equal to 90. If we'll take the theta equal to 90, so what will happen? So let's see. QUB sine 90 degree. So it will become QV. Okay, now you know it is a circular path. Okay, this is a circular path. So here force will be applied as centripetal force. So which is half mv, which is mv square r. Okay, so let's go. Put here mv square r. So it will become QV. So now cancel Q, now cancel V from each side and shift the R here. So it will become mv by QV. Okay, that's it. We find the R value. Now we are moving to the kinetic energy. Okay, so what is the kinetic energy here? Kinetic energy, we know it's half mv square. Now multiply m both side. If you multiplying m both side, it will become mv whole square by m. Okay, now what you need to do is you should know mv. Like from here, if we see mv is what? Mv is equal to qbr. Okay, from here mv is equal to qbr. We will put mv value here. Okay, now put mv value here. So we'll have qbr square whole square by m. So it will become half qbr whole square by m. So it is a kinetic energy. Okay, so it is a kinetic energy. So that's it. So view the all of this equation. Okay, now we're moving to find time frequency. No, not time period. So what is the time period here? So t equal to 2 pi r by v. Now from r we know r is equal to mv by qb. So put r value here. So if you put here, you will get 2 pi mv by qb. V will get cancelled. It will become 2 pi m by qb. Okay, so t time period. Now for frequency, we know frequency in inversely proportional to time period. Now it will become q by b by 2 pi, just opposite of t time period. Okay, frequency. So now you know the frequency. Now you know the time. Now move for angular frequency, which is 2 pi of frequency. So we know the frequency. Put the frequency where here? Frequency value here. Okay. So frequency is equal to qb by 2 pi m. 2 pi will be cancelled. Here is left qb by m. So we found our time period frequency. Angular frequency is called the gyro frequency. Okay, it's also called the gyro frequency. Time period frequency, angular frequency, angular frequency, radius, and kinetic energy. So this is the equation. You look at this equation and also look at this equation too. Okay, so we are done. Hello friends, today we will know the magnetic dipole moment of a revolving electron atom as a magnetic dipole. So what is magnetic dipole? This is a magnetic dipole. It is equal to IA, current and cross-sectional area. Okay, so we should know, we will find this value. Okay, new value. So we know the angular momentum. Angular momentum is mvr, and current is q by t. Okay, q by t, but here the charge is electron, and electron is represented by E, so E by T. Okay, and also we know the time period. Time period is 2 pi r, which is a full circumference of a circular path, and by V. V is the velocity. Now what we'll do, we'll put T values here. Okay, put T value here. So it will be 2 pi r V. Okay, take this as equation 1, and we know u equal to Ia, which is a dipole. Okay, which is a dipole moment, magnetic dipole. Okay, which is a magnetic dipole. So now what we'll do, we will put I value here, and we know area is pi r square. Area of a circle is pi r square. Pi will be get cancelled, r will be get cancelled, so we're left with EV r by 2. So it is a new, it is also an important formula. Now we'll move to finding its all. So we know L equal to mvr. Okay, but here L by m, take L by m, which is equal to VR. Now put this value, take this is equation 2, take this is equation 3. Okay, put equation third value in equation 2. Okay, so when you put this, it will become E by, it will become E by 2 L by m. So it is not accomplished now. So we know it is a electron charge. Electron is a minus charge. Okay, it has a minus charge, so we'll write the minus here, and it is the mass of an electron, so we'll write mb here, like this is m, and we should write it E as this. Okay, this is m, so 2m E. It is a symbolic of mass of electron. Okay, and it is L. We proved it. So this is gonna what we had to prove. We proved it. Okay, this is done. So how we did? We know nu is equal to Ia, L is equal to mvr. So we used L by m is equal to VR, and we put T here, and you will get here, and when we are putting this, you will get this, and after that, this value, like put this third value in second value, so you will get this, and we know the electron charge is minus E, so we'll write minus E, and we represent m is mv and L is the L. Okay, so that's it. Hello friends, today we'll know the magnitude of torque acting on a current loop. So this is a torque, and torque is equal to half. This is what we'll taking it. We'll applying force here and here, F1 and F2, and F1 and F2 is equal to BIL. Okay, BIL. Now while adding the two forces together, so it will become IL BIL B, and length into breadth, we know length into breadth is the area, so it will become area when we are making it cross product of A and B, so it will become A cross B, and this is I, and this is the tau. Okay, so that's all. Thank you. Hello friends, today we'll know about the conversion of galvanometer into voltmeter. So what will happen? We know the V is what? IR. So we'll take IGR, okay, plus the IG current is passing through galvanometer and R, so it will be IGG also. So we need to find the R resistance. So finding the R resistance, what we need to do, we need to subtract V minus IG. Now divide IG to its right side, okay. So while you dividing it, to get this, so this is a R, this is what we gonna find, and this is what we have. So that's it, this is all about. Thank you. Hello friends, today we'll know the formula of which is required in conversion of galvanometer in ammeter. So the conversion of galvanometer into a ammeter is represented as, like, this is a galvanometer, and when current is passing through, then it will divide IG for a galvanometer and I minus IG for a shunt resistor, okay. So go ahead. So we know I into G is the resistance, is equal to the I minus IG S, okay, and S is equal to IG by I minus IG. So that's it, that's all. Thank you. Hello friends, today we'll know the angular speed of a circular carrying loop or a coil about its diameter in the presence of a uniform magnetic field, okay. So simply we're going to find the angular speed, which is the omega, okay. So here we go. So we know the tau is what? Tau is magnetic moment into magnetic field into sine theta, okay. And we know that tau is equal to dl, differentiation of angular momentum by with respect to time. So we know L is equal to I omega, so we write I omega here, and when you differentiate it, it will become I will become out, and it will become d omega by dt, and tau will be the mv sine theta, okay. Now what you need to do is you should take d by dt, and you should multiply d theta by d theta to the numerator and denominator, and now d omega d theta by dt, and this is what you need to do. So d theta by dt will become omega, so it will have d by d theta, okay. So instead of this, you can write this is equal to d omega by dt, okay. So instead of d omega by dt, you can write omega dw by d theta mv sine theta, okay. So now split this value, ib by, will multiply cross multiplication will have this, and sine theta d theta will be this. So we left with omega d omega. Now integrate with the omega naught to omega, and sine with what? 0 to theta. Now you know the integration of sine theta. Integration of the sine theta would be minus cos theta, and the limit is 0 to theta, and here is like omega square. Omega square is the value of this integration. So now what you will do, here is like minus cos theta minus cos theta 0, so you need to take it minus as a outside, okay, minus as a outside, and here omega square, here is also omega square by 2. Okay, omega square by 2. Now it will omega square 2 omega naught square 2. So what you need to do, finally we have this equation. So instead of cos 0 we'll write 1. Okay, so it will 2. It will not 2, sorry, it is mv by I cos theta 1. It is half omega square omega naught square. Now what we'll do, we will cross multiply this. Okay, it will left omega square by omega naught square. Okay, and this is the final equation. Done. So see this, also the last one. Okay, thank you. Hello friends, today we'll derive the magnetic field on the axis of a circular loop or a coil carrying conductor. So this is a circular loop. It has a radius r, distance x, and hypotenuse small r, which is equivalent to under root r square x square. If we take the component of, if here is a theta, so here will be the theta. So its vertical component will be dv sine theta, and horizontal component will be dv cos theta. So here we'll use. Okay, so first of all we should know about the cos theta. What is here cos theta is? So cos theta is base by hypotenuse. So here is the base r and hypotenuse is this. So r is square plus x square. Okay, so this will be the cos theta we'll use. Now we know B. What is magnetic field is here. Magnetic field is equal to the close integral dB cos theta. Because the sine dB theta and sine dB theta will cancel each other, so there will be left only one force, which force not, it's not force, it is a magnetic field which is left. Then we'll cancel the vertical magnetic field. So here the only thing will left is dV cos theta. Now we'll go. So we know cos theta value is r by under root r square plus x square, and dB is equal to u naught by 4 pi I dl by r square. It is from the Biot-Savart law. Okay, exactly I'm pronouncing the Biot-Savart. Okay, Biot-Savart. Okay, now we'll move to put this here in this equation. So put I dl by r square. So r square is what? R square is equal to r square is capital R square plus x square. Okay, so this is the r square. Okay, when you square this, we have the result, which is capital R square plus x square. So when we'll multiply, it will become rx square power 3 by 2 I r and the close integral of dl. So here the dl is the distance. So what is the distance of this circular loop? So the distance of the circular loop is 2 pi r. So here we write 2 pi r. Okay, dl is equal to 2 pi r. So we write 2 pi I, it will become I r square and r square plus x square 3 root by 2. So So this is our B. Look at the whole term. Okay. So this is our equation. What we got at the end is B is equal to u0 by 4 pi 2 pi I r square by this. Okay, we got this. So at center, okay, at center what will happen? At center, okay, at center x is equal to 0. If x is equal to 0, we left with b equal to 2 pi I by r. Okay, so this is what we left with. So this is the main equation. If I'm plotting the graph, it would like minus 2r r by 2r. Okay, it is as like this. Okay, so from here it is a magnetic field. So look at this question. Thank you. Hello friends, today we'll compare the electric and magnetic forces together. Okay, so here we go. We know the forces. Okay, magnetic and electric and magnetic forces. Okay, so here we go. So we know the electrostatic force, which is 1 by 4 pi absolute naught q1 by q2 r square. But here we know the magnetic force is u0 by 4 pi I current first, current second by r square, and here is dl1 dl2. Okay, this is the magnetic force. But if we'll taking as d1 dl, so we know the I is equal to q by t. I is equal to q by t. Okay, so we know dl by dt will become the velocity. If considering the dl1, so it will become the velocity 1. Okay, so it is the q1 v1. So similarly I to dl 2 will become q2 v2. Okay, now put this value here. Okay, now the magnetic force will become q1 q2 v1 v2 by r square. So take this as equation 1 and take this as equation 2. So divide. Now what you need to do, you need to do the division. Okay, so here it is all about. So while we'll dividing, like we'll dividing fe by fm. Okay, so this is a 4 by absolute naught q2 by r square is divided by 1 by u0 by 4 pi q1 q2 by r square v1 by v2. Okay, so after so solve it. First of all, try to simplify. Okay, now we'll simplifying it, so it will become 4 pi u0 q1 q2 v1 v2 by r square. Okay, so here q1 4 pi r square will be the cancel, and we're left with u0 absolute naught v1 by v1 into v2. Okay, so it will the fe by fm. Okay, fe by fm. So it is the fe by fm. Now what we'll do, we know the speed of light is equal to 1 by under root absolute naught and mu naught, and when we're taking it as a square, it will become this. Okay, so instead of this we can write h square, like instead of u naught or absolute naught, we can write h c square here. So c square by v1 into v2. Okay, now what we'll do, we know the vd, the electron, the velocity of an electron is 10 to the power 5. We can find it by experimentally. Okay, and c, the speed of light is 3 into 10 to the power 8 meter per second square. Okay, when we are solving this equation, so let's solve this equation. Okay, 3 will become 9 power 8 will become 16, and here it will become 10 to the power minus 10. So it will become 9 into 10 16, so take it as a plus 16. Okay, 9 into 10 to the power 26, approx 26. Okay, so this is the value which are we getting. So it is the final. If you can also see, this is also the last one, but value need to put out. In some book it is written as like it is equivalent to the 10 to the power 27. Okay, then in some books it is written this. Okay, whatever you shoot, you will do. Okay, whatever you will think is right. So this is the first one, and this will be the last. Okay, thank you.